We're skipping ahead now to some problems from section 6.5, which was about the definite integral. So we're still applying the same concept to each of these problems. We want to evaluate this integral using substitution, but then we're dealing with a definite integral, so we're going to evaluate that function at the upper and lower bound, find the difference of those two results to come to some real number as our result. So we're still looking for that interior function, in this case 2x plus 4. So we're letting u equal 2x plus 4, which means du is going to equal 2dx, or we could rewrite this as du over 2 dx, so that again we can substitute our denominator with u, and in place of dx, we can substitute du over 2. That means our integral becomes 1 over u times du over 2, and that's going to be evaluated from x equals 0 to x equals 1. Now, usually we just write that as the integral from a to b, but in this case I want to be specific to indicate that those two values relate to x, not to u. So after we integrate, we'll have to rewrite this problem in terms of x to make sure we're plugging in 0 and 1 for x and not for this new variable u that we've introduced. So we have du over 2, where 1/2 again is just some constant multiple. So we have 1/2 times the integral from x equals 0 to x equals 1 of 1 over u du, which will be 1/2 times the natural log of the absolute value of u, and then we would have plus some constant c, but as we've seen in each of those previous definite integral problems, plus c, that unknown constant ends up canceling out when we evaluate that definite integral. So I'll just leave that off and we'll evaluate this from x equals 0 to x equals 1. Now again, keep in mind we can't make these substitutions yet because these are x's, values for x, and this variable is u. So the next step is to rewrite this indefinite integral with this original expression that we substituted in for u. So this would become 1/2 times the natural log of the absolute value of 2x plus 4. And now that can be evaluated from x equals 0 to x equals 1 because our resulting indefinite integral now is in terms of x again. So this will give us 1/2 times the natural log of 2 times 1 plus 4. So times the natural log of the absolute value of 7. Not times 7. 2 times 1 is going to be 2, plus 4 is going to be the natural log of the absolute value of 6, minus 1/2 times the natural log of 2 times 0 will be 0, plus 4, so times the natural log of the absolute value of 4, which will be 1/2 times the natural log of 6 minus the natural log of 4. So just factoring out that 1/2 that's common, and then the absolute value of 6 is just 6. Absolute value of 4 is just 4. We have another property of logarithms that will allow us to rewrite this as 1/2 times the natural log of 6 over 4, or 1/2 times the natural log of 3/2. So we can take the step to rewrite that, or most of these problems are typically looking for an approximate result. So we can either plug this expression into our calculator or this one, and either way we should get approximately 0.203.